How's it going, everyone? In today's video we're going to be looking at the difference in speed between Python and Rust. And this video isn't going to be technical or anything, it's just going to be about a couple of programs that I created that demonstrate the difference in speed between Rust and Python. So here I have Rust and Python side by side, and both of these files perform the exact same task. And just to explain it, I start by importing instance, which will help me with timing the code in Rust. Then for I in range 1 to 1 billion, we're going to check if I is divisible by 100 million, then we're going to print I. And this check here just prevents me from spamming the console. Then at the end of this for loop, we're going to check how much time has elapsed, and we're going to print that to the console. Now in Python, we're going to do the exact same thing. And to do that, we will start by importing the timeit module, and then we're going to loop in the range of 1 to 1 billion and 1. Because I want 1 billion to be inclusive. And in Rust, we can make it inclusive just by including the equals. And then if I is divisible by 100 million, we're going to print I. And to time it, we're just going to use the timeit module, and we're going to run our main function once. And then we can print the elapsed time. So now that we know what the code does, let's run both of these programs. Starting with Python. So here I'll type in Python 3 main.py and tap on enter. And while that is loading, I'm going to type in cargo run in quiet mode. And this is the same program being run side by side. On the left we have Rust, which finished in 6 seconds, while on the right we have Python, which is still looping through the range of 1 billion. And at the end of this benchmark, you'll notice that Rust only took 6 seconds to execute this task, while Python took 26 seconds. So in this case, Rust was clearly superior. And the code here is nearly identical. It didn't take that much more code in Rust to get this performance boost. But now it's time that we move on to the second benchmark. And once again, I'm going to explain the code before we run it. So here we have a main function, which starts by printing that we are starting the benchmark, then it grabs the current time and starts this task. So here what we want to do is loop in the range of 300 million, and if the current iteration is equal to 150 million, we're going to print halfway, just so the user knows that something is happening. Also, for each iteration, we're going to add to the current sum. Then after this for loop, what we're going to do is grab the time, and we're going to print that the sum is the current sum, and that the elapsed time is the elapsed time, formatted nicely to 2 decimal places. In Python, we have the exact same operation, except written in Python, of course. So once again, we're importing timeit so that we can time our code. Then we have our main entry point, and we create a variable called sum. Then for I in the range of 300 million, we're going to check once again whether I is equal to 150 million, and if it is, we will print halfway, just so the user understands that something is happening. Then at the end of each iteration, we will add the current iteration to the sum. And finally, we're going to print that sum at the end of our main function. And I just noticed that this should be above the let duration to really make this accurate, even if this statement is quite insignificant. And before we start timing the code, we're going to print that we are starting this benchmark. And after we time the code, we will print the total elapsed time, formatted to 2 decimal places. Now let's open up the terminal and clear both of them so that we can run this code. And as always, I'm going to start with Python. So here we can type in Python 3 main.py and start running that code. Then I can type in cargo run in quiet mode. And there we're starting the benchmark. It's going to print halfway. And the total elapsed time for Rust was 1.66 seconds, while the total elapsed time for Python was 9.8 seconds. So once again, Rust dominated in this benchmark, and it didn't even take that much extra code to get that performance boost. Now, does this mean that you should stop using Python? The answer is no. I absolutely love Python. It's one of the easiest languages to use in the world. It has so many use cases, and it doesn't require you to use a semicolon at the end of each statement. It's a very simple language that allows you to glue functionality together without putting much thought into it, and is still used for some very professional applications in the real world. But if performance is critical and you really need that performance boost, opt in for Rust or another low-level language. I'm not comparing Rust to C or to C++, so if you want to find out the difference between Rust and those languages, you're going to have to perform a different search. All I wanted to show you in today's video was the performance difference between Python and Rust. Anyway, I would love to hear your thoughts on this video in the comment section down below, and that can also be regarding what you use Python for versus what you use Rust for, if you're currently using both. Otherwise, that's actually all I wanted to cover in today's video, so as always, thanks for watching and I'll see you in the next video.